Okay, propose that we get started. We're a little bit in a weird configuration. Most of the presenters are remote, so we'll see many people on the screen, and then we are conflicted against a BOF. So it's a bit of a strange situation, but it doesn't matter. Pascal, could you get first slides?
So I'm using the agenda to click. You people used to it. So when you're on the agenda main page, you can. When you're in the agenda main page, you can click on 6TISCH. You get this 6TISCH material. So you've got the agenda, and then you've got the documents. So just click on one, and you can start.
Okay, so welcome to the 6TISCH workgroup meeting. This is an IETF meeting, so I need to remind you of the note well. The note well applies to this as it applies to any IETF meeting. If you're discussing any IPR, whether it's yours or not, you need to disclose it. If you have any questions, read this note well. Go through different references in this note well and ask your favorite workgroup chair or AD. Reminder, we are taking minutes. Where are our minute takers? Dominique should be somewhere. Federico is here. Thank you. So Federico, if you could take the lead, and then Dominique will jump in and fill in. We're recording, and all of this will be sent to the mailing list after the meeting. We will circulate some blue sheets as well. So trivial stuff. Minutes are here. Remote participation. Meeting materials are online, etc., etc. We're going one set of slides per presentation, makes it much simpler for us. This is the agenda of today. So as I told you, most of the presenters will be remote, which is a kind of a weird situation. But we'll start by doing some intro and status, agenda bashing, milestones, and state. We then go into first half, which will be about chartered items. Xavi will present the 6TISCH protocol. Malisha will present the minimal security solution. Michael will present the zero-touch join, and then Diego SFX. And then we'll go, if time permits, into the uncharted items. We have about half an hour for that. With Tengfei and minimal scheduling function, we'll have SF1 with Remy here, and then Michael again. Oops, that's good. Michael with joint priority. And then at the end, we have 10 minutes of non-scheduled space for any other business. If there's any updates, then this is where we want them. So before we get started, is there any comments about this agenda? Anything we want to add, we want to remove, we want to discuss, we don't want to discuss? If you have any issues, please raise them now. Okay, I hear nothing. So let me give you a quick status. The milestones. So while I'm speaking, Xavi, you'll be the first presenter. So I don't know whether you need to click on some magic, but you'll be speaking. Will he show up in the queue? Is that how it works? Okay. I think Miteko somehow magically scheduled him. We'll see. So we've completed the initial submission of the 6TISCH protocol, the 6P to the ASG a couple of days ago, and it was just transitioned from submitted to under I forget what the term is, but it was accepted and is looked at by the ASG. So we should have some reviews rolling in the next couple of weeks. I wanted to take a minute or so to. This is a rather dense slide. I had 14-hour flight just now, so this is what 14 hours of flight gives you. Lots of colors and arrows and stuff. What I wanted to show you is a state of the working group, and bear with me. I'll try and read this with you. So. In the upper left-hand corner, we have completed a minimal 6TISCH solution, which is fantastic news. Everything works. We can now go out and build fully standards-compliant 6TISCH products. And by minimal 6TISCH, I mean 6TISCH minimal, 6TISCH minimal security, minimal scheduling function, of course. Xavi, we can hear you.
Sorry.
And then Ripple 6550. And 6LoWPAN. So that's That's great. It's the first time that, I mean, we're there now. We have everything. We have a solution, a minimal solution that works. And I think as a working group, we have two different elements to work on, something internal within the IETF and something external. Let me start with the external. As a working group, it's important that we support adoption of this technology throughout the market. And so there's a number of actions that are going on right now, not within the IETF, but a little bit on the fringe. Performance evaluation, questions like, is 6TISCH the right technology for my application, is what implementers are asking themselves. And so all of these open source implementation now support 6TISCH. Contiki NG, which is like 3 days old, is the last one that was announced. That's great. And there's a bunch of activity going on in performance evaluation and benchmarking, which is exactly what we need. We need to be able to tell, company X, Y, and Z whether for this particular application 6TISCH will work. And there's also tools that have been built around conformance and interop testing, such as interop. So it's a good thing. Now, internally to the working group, internally to the IETF, there's, based on this minimal 6TISCH, there's further technology developments in 3 areas. The first area is additional scheduling functions. So there's 3 ongoing works: SFX, ASF, and SF1. The ones that have a star are the ones that are presented today. A second focus point is security, with the zero-touch join security. So taking the one-touch solution of minimal security and turn that into a zero-touch solution. Michael will present this. And then a number of optimizations regarding Ripple, regarding EVs, join priority, elements that you put in the DIOs, elements that you put in the EB to make join faster, more flexible, things like this. And so this is ongoing work right now in the work group. Now, as a working group, we need to make sure that we have some criteria for extending the minimal 6TISCH solution with different additional ongoing work. And so we're thinking about what those criteria could be. This is not a final list, obviously, but it kind of gives you an idea of the state of mind we're in. So if you're working on something that goes and adds stuff to minimal 6TISCH, is the specification that you're writing, what exact problem is it solving? Once that specification is in place in the implementation, how much better will the network work compared to minimal 6TISCH? And then if you pull in a bunch of RFCs, then how much bigger will the footprint be of your implementation? Because that's something we cannot forget as well. So this concludes, I think, this.
Before you leave this slide, I wanted to say that in the last Ripple and EB optimization, this is the continuation of a long story at 6TISCH where we've been looking at things which are needed for the broad picture, writing down initial papers or documents inside 6TISCH to make sure that's what we want, and then go to different groups to get the work done because the work belongs elsewhere. And in this list, you see that there is DIO, which belongs to Ripple. There is fast reroute, which also belongs to Ripple. And those are things that we start here, but will not do here. We'll be asking, for instance, in us for role about those DIOs and fast reroute things. Some things which deal with the extended beacons may be done to some point here, and maybe discussing with Charlie and Bob in this room, we might decide that this is going to end in IEEE. I don't know. Right. First, we need to solidify, clarify the idea, and then we see if it has to happen and where it has to happen. So it's not because it's in this list that we want the whole work to happen here. We have a long story of doing things at ROLL, at 6LO, etc., which started here. That was it. So.
Any remarks about this before we move on? All right, then I propose that we get started with our pretty dense agenda. And Xavi will give us an update about the 6-stop protocol. Is the note taking going well? Federico, could you log in? Okay. Dominique as well. All good. Xavi, the floor is yours. Let us know when you want to flip slides. I think that's the easiest.
Okay. So hello everybody. Good afternoon. Good morning from here. I'm gonna explain a little bit what we did with the 6P
Xavi?
protocol. Yeah.
Can you please put your mic farther? It seems that all the rooms have the sound very loud. Even farther than that's going to work.
Further, like this.
Yes, it's better.
Okay. So I'm gonna go through the 6P protocol, and I'm gonna give just a status update of what's going on with it. So next slide. This is a very stable draft. We are now in version 9, and we didn't go back, please. Can you go one slide back?
Back?
Yeah.
This is the first slide, Xavi.
Because I see the second one. Now, this one, sorry. So we addressed the comments we received the mailing list, and then we did several improvements, basically for readability, fixing minor typos, and so on. And then we clarified the three points that we think that from the comments were not clear. So this first one is relocation, and there was a thread in the mailing list as well discussing that. The second one is how we handle inconsistencies. And the third one is the error codes, and we try to clarify at least the error codes and how they are used. And this draft was submitted to the ISG since the 31st of October. So now I think it's in review status. Next slide, please. Yeah. So the first thing we did is we tried to clarify relocation. The important thing for relocation is that we submit this command, and with this command there's two lists. One is the cells that want to be relocated, and the other one is a candidate list. One thing that was not clear is that the cells in the candidate list are all them equivalent. This means that any of, and you will see it in these examples, but it means that any cell can be relocated to any of the candidate cells. And if we look, for example, at the case A, where we have here an example where all the cells are relocated, we will see that there are two proposed cells, and the first one is matched. It can be relocated to the last one in the candidate cell list, while the second one that needs to be relocated is relocated to the first one in the cell list. And this is just a decision on the implementation because all of them are equivalent. We have other examples like case B, where only one cell from the two that want to be relocated is relocated, or in the case C, when none of them can be relocated. And here we can see how the protocol works and what is the signaling we have. Next slide, please. Yeah. So then we tried to clarify inconsistency handling. Previously, we had in the header a counter, we call it generation, but then after in the last IETF we had extensive discussions on whether that field is needed or not, and at the end we decide to just remove that field and go with the sequence number, and with the sequence number being able to identify when there's an inconsistency. To be clear, an inconsistency is when the cells in the schedule of two nodes, A and B, are not consistent. That is, that one cell is allocated on one side, but maybe in the other, for some reason, it is not allocated. And this can cause problems such as losing connectivity between two nodes. And there's many combinations of possibilities, but they kind of fall into these two examples. The first one is when we have a transaction ongoing and the node B, let's say in this figure, for some reason resets or power cycles, and then it restarts. If this happens, the inconsistency will be detected because of the sequence number of the node that resets turns to 0, and then this will be detected in the response message. While another case is when we have a transaction and for some reason the last link layer acknowledgement fails. So we have the responses from one of the sites, and for some reason the acknowledgements are not received, and after as many retransmissions are configured, we cannot acknowledge the message, then that site detects that there's a possible inconsistency. Then in the text we clarify how these inconsistencies are addressed, and we just outline recommendations, or we just indicate what can be done, because we think that the scheduling function has to take the decision on what exactly to do. One option, of course, is to reset the schedules, and other options are like roll back the transaction. Next slide, please. Yeah, we finally we clarified the error codes. We've gone through all the document. We tried to identify all the cases where an error code is returned, and we tried to make the text as clear as possible. And then we sorted them in this table, also considering whether they are just response codes, not without meaning that there's an error, or if they are or if they have to be considered an error. So this is the list of error codes that we have identified. And next slide, please. Okay, so this is about this draft. As I said, is very stable, and it's kind of in the last hop, I would say. So if you have any question.
So thank you, Xavi. So I think this also reflects well what we discussed in Prague, and all the changes that we have done after the plug test there. I know of at least 2 implementations that implement this version, although it's yeah, I think can you say something about NG? Is it this version, or is it the previous version that's implemented? The previous version that's implemented. Okay. So we're waiting on one more implementation and to update to this one. Thank you. All right. Any questions? Yes, right here.
Nothing really in particular, but I would like to see the IoT there come out, the IoT there.
Yeah.
To do the review of this and see how it comes out. Like, it just came in just before the meeting.
Yeah.
So I'm not gonna. So most likely nothing's gonna happen to it until Christmas, I would think, right? Like, so 2 weeks of like IoT there, like inter reviews, and if Xavi turns around very, very quickly, I can get a last call started and schedule it on telechat beginning of January. That's kind of like my timeline.
Okay. And I've seen that Samida sent the email to the IoT Dear to ask for it.
Right. And I think like she wanted 6law to take a look at it as well.
Yeah.
And she asked me, like, should I tell 6law? It's like, yeah, you should, right? Like, as long more reviews are better at any point of time. So like she said, like she'll just like fan it out and see how things go. Right.
Perfect.
And like I took a quick look and things look okay to me, right? But I'll wait for like IoT review as well.
Thank you. Perfect. Thank you. Thank you for the update. Thank you, Xavi.
Thank you. Have a nice day.
Thank you. Stay online, because there's actually feedback from, if I remember correctly, from the MSF implementation about this.
Okay. Yeah. Sure.
Yep. So the next presenter is Malisha. I don't know if Malisha, if you can hear us or see us. Talking about minimal security, so the one-touch security solution that builds on top of it. And is Malisha on the list? There you are. Yeah, we see you.
We cannot hear you.
Can you hear me now?
Yep.
All right. Sorry about that. I forgot to join the queue and enable the buttons. So the sound is good?
Yeah, perfect. Thank you.
All right, great. So hello, everyone. My name is Malisha. I will be presenting the status of minimal security draft, which is our one-touch solution to secure enrollment in 6TISCH networks. So on October 30th, we published the 04 version of minimal security. And the biggest change is that we now completely rely on pre-shared keys. That said, we had to remove the dependency on the ad hoc draft that did not see any progress. So as of now, minimal security completely relies on pre-shared keys. And we will be addressing the asymmetric keys probably as part of the zero-touch work. As part of this presentation, I will go through the main changes that we did from 03 to 04. Next slide, please. Yes, so the update number 1 relates to the key nonce derivation process, and mainly as we heavily depend on OSCORE spec that is being standardized in core. OSCORE was formerly known as OSCOAP. OSCORE went through some changes when it comes to the key nonce derivations process, which we had to adapt to. And this was the reason why we had to do quite some changes in our draft. So right now in OSCORE, same nonce is used both for join request and join response, but it is used under a different key. And because of the way they construct nonces right now, we could no longer use the concatenation of the nodes pledges identifier and byte string 00 and 01 to differentiate between the pledge and the JRC. What we do now is that we use pledges identifier as master salt during key derivation process. And then we transport this identifier EUI64 as a context hint during as part of the join request. I will present some more detailed slides just in a minute. And we use the different identifiers, of course, for the pledge and the JRC. And this is plain simple. It's 00 for pledge and 01 for the JRC. I made some slides to reflect some schematics to reflect this. They are presented in the next slide. Yes. So this is what the key derivation process looks like, and this is basically standardized in OSCORE, and we instantiate this in minimal security. And as you can see, the first input to the key derivation function is the pre-shared key, which is kept secret, of course. Then, as master salt, we use pledges identifier EUI64. Then a string key to differentiate between a key and the IV that is subsequently being derived. And also there is the sender identifier. When this all is passed through a key derivation function, we obtain a join at the key that is used to protect the join request. And for the join response, next slide, please. What changes is only this sender identifier. This sender identifier that corresponds now to the JRC, but that both nodes need, that both pledge and JRC need to have, of course. And with this we end up with the join response key. Now, when it comes to nonces, and as I said in 03, there was a difference between the nonce used for the join request and the nonce used for join response. But since join request and join response use two different keys, what OSCORE authors did in their spec is that basically now they use the same nonce for the request and the response. And this is how we instantiate these in minimal security, where again, PSK is passed through the key derivation function together with the pledges identifier. This, as the output, gives a static IV that is kept on both sides. And then to construct the nonce for each request that comes or a response, what happens is that this common IV is XORed with the sequence number together with the sender identifier of the entity initiating the request. Next slide, please. So the second major update was regarding the error handling. And it turns out that the error handling in 03 would open the pledge to a denial of service attack. where the attacker could send unprotected co-op error messages to the pledge, which would get accepted at the pledge, and this would force the pledge to attempt joining the next advertised network. This was the case because in case the pre-shared key is not present at the JRC, or that the pledge is not authorized to join the network, the error handling that we used previously would return an unprotected error code back to the pledge. Now, of course, as this error code cannot be protected, because the JRC and the pledge do not share a common context or the pre-shared key, the pledge, it would be possible to spoof the error response and make the pledge join the next advertised network. And what we did in 04 is that we went for completely for silent drop of any error codes. And to do that, we use non-confirmable co-op message for join requests, which makes OSCORE at JRC silently drop the request in case of failure, which may happen for failed decryption, replay attack, or simply an unauthorized pledge joining. So what we mandate now in minimal security is that the pledge must silently discard any response not protected with OSCORE, including error codes, and this is to ensure that the client, or basically the pledge, does not accept any unprotected messages coming its way. This is also good from the point of view of intermediary state that the join proxy keeps when it forwards the join request. Because it minimizes this state that the proxy needs to keep in terms of co-op, in terms of the co-op implementation. So it fits very well with what we wanted to have, basically the stateless forwarding at the join proxy, but it forces the pledge to implement a retransmission mechanism at the application layer, which basically duplicates co-op confirmable message functionality. And next slide, please.
Please, Marisha.
Yes. Yes.
This is Thomas. Clarifying question.
Yes.
Sorry, I didn't quite understand. So, the pledge sends a join request to the JRC that used to be confirmable. Now it's non-confirmable.
Yes, that's correct.
Because the reason is, if I'm a pledge and I send a join request and some attacker sends me a join reply telling me, hey, you're not authorized, I'll believe it because it's not encrypted. I didn't get the keys yet. Correct?
Yes, that's correct. Yeah.
And so we say, okay, non-confirmable, so there's nothing that comes back from the JRC.
In
correct?
case of an error, yeah.
In case of an error.
Yeah. If
okay.
everything goes smoothly, we return as before, we return the join response.
I see. Sorry, secured with a join.
Yes, of course. Yes.
Okay. So if I'm a pledge and I send in a join request, if I get a join response, if everything's okay, I get a join response. If something goes wrong, either I'm not authorized or just some communication goes wrong, then I don't get anything back. So it's either a positive feedback or no feedback at all. Is that correct?
Yes, that's correct.
Okay. Thank you.
Yeah.
Yes, I understand that. Marisha, clarifying again, sorry. I understand that if there is some configuration error or something, the device will retry to death, and then it will stop at some point, right? And
yes. So yes.
So
exactly.
so it is the responsibility of the GRC to send some management error to whatever management, so to go and fix the device, because there's nothing that will fix the device, right?
Yes, but
so
the problem is
that the GRC to notify that the non-recoverable error has happened and tell an administrator of some form.
Okay, so I see what you're saying. Basically, right now, as it is in the draft, the pledge would need to detect this. And we say that upon a certain number of retries, the pledge should signal to the user by an out-of-band mechanism the presence of an error condition. This is the statement that we have in minimal security. But your point is good, that basically at the JRC side, if there are many attempts that fail, this could be a sign of an attack or a misconfiguration of some pledge. So yeah, this is a good comment. This is something that we should probably add.
This is Thomas. That being said, Pascal, I mean, this is regular. It doesn't require any protocol changes, right?
No, it's well, there must be a management. Something should be written that the management event should be sent to whatever management console, because I expect that many of those devices will not have an out-of-band channel to report the error.
Yeah, I was
Unless you
thinking of
send
like
somebody
LEDs
to-
or something like that.
Either.
Thank you.
Yeah, so this brings me to what we discussed just now forced us to implement basically the join request retransmission, which details a bit this discussion that we just had. And right now what we do in minimal security is that we mandate a binary exponential backup mechanism to be implemented by the pledge at the application layer. That kind of duplicates the co-op confirmable functionality, but we found no better way of doing this. And so one reason why we had to use the non-confirmable co-op is because of security, and the second reason is that it minimizes state at the proxy that is in the middle, and it relieves the proxy from keeping state from many untrusted pledges, basically. And the mechanism that we specified is very simple. It's inspired by the one in the co-op RFC in 7252. Pledge only keeps track of a timeout and a retransmission counter. Upon a timeout, it increments the retransmission counter and doubles the timeout. And we specify in the draft some default values. So basically, for the initial timeout value, we use 10 seconds, which gives us on the first attempt timeout in 10 to 15 seconds, and at the very last attempt, by default, it gives us a timeout in 80 to 120 seconds. So I will be playing also with the simulator to further confirm these values for a wide range of networks. But this, at the moment, I think they give a fairly confident number of retries from the pledge point of view, and they are not too consuming in terms of energy, as there will be only 4 retries. Yes?
Sorry, question from Thomas.
Mm-hmm.
So now we do a non-confirmable co-op join request, and then we implement essentially something similar, not the same, but something similar in the JRC to confirm it, essentially.
At the pledge.
Is it? I'm sorry?
At the pledge. So the retransmission, because we have a proxy in the middle, right? So proxy statelessly forwards the request when it receives the request from the pledge to the JRC.
Yeah.
There is no retransmission by using non-confirmable co-op. There will be no retransmission from proxy to the JRC. But what we do is that we mandate that the pledge initiates a retransmission in case it doesn't receive something in this timeout.
Okay. Yeah, let's just go offline because I have some weird ideas, but I'll get shot if I say them here.
Okay.
Let's just offline.
Yeah. Other than that, we added some recommendations to store untrusted neighbor entries in a separate cache, as there would be a possibility to flood the joint proxy with malicious pledges and basically do a denial of service on the joint proxy if the joint proxy would keep the entries from the network and from the untrusted pledges in the same neighbor table. We switched the join request from get to post in order to be more flexible with payload in the join request down the road. At the moment, we do not specify any payload in the join request, but it could be useful down the road. Further, we clarified some text on the persistency of mutable OSCORE context parameters, which ensures that there is no nonce reuse and replay attacks across reboots. And we also did an extensive editorial pass, rewrote, introduction, clarifications on the pre-shared key, and many others. Next slide, please. So as I said, we now completely rely on pre-shared keys. Most of the changes in 04 were due to the changes in OSCORE, as well as this problem that we found with error handling. There is an ongoing thread on the mailing list about tagging join traffic, which unfortunately I didn't have much time. I had to context switch to minimal scheduling functions, so I didn't have time to follow through. So you guys are probably more advanced than me on this, but I will be going through this thread in the next days, and I think there is, from what I could see briefly, is that there seems to be a resolution that we tag join packets at the join proxy by using toss bits in IPv6 header. And Pascal, if I understood correctly, this would cost us 1 additional byte in the join request packet.
Right. I mean, there will be a default value that you don't need to indicate. So in the data packet, you would not see it for most normal data packet. But actually, this is a new weapon we have to improve the SF. Is if we have a different number of CS or classes that the SF recognizes, then it would have different treatments and maybe allocate more, allocate less, or in this case, allocate nothing, depending on the class of the packets. So if you use a default class, use 0 byte. If you want to indicate a class which is not the default, you will use 1 byte. Yeah. Okay.
And I assume this will be opaque to the regular IP routers, as the join request may cross when it exits the 6TISCH boundary to get to, in the case GRC is in the cloud, it would cross regular routers, right?
Oh, it's diff serve, right? So the meaning of this byte is local, and after that it can be rewritten.
Okay. All right. Sounds good. And yes, we think the draft is fairly stable now, and we always welcome some further reviews.
Rahul Jadhav from Huawei. You mentioned in the previous slide, you mentioned about untrusted neighbor entries. So there is a work going on in LWIG specifically to handle this particular case. It not only considers this case, but it gives an example of EAP PANA, but the same applies there. So we would like to have you check that particular draft to check if this makes sense. You know? So the first point, recommendation to store untrusted neighbor entries. So there is a draft in LWIG which specifically talks about maintaining neighbor entries in 6LoWPAN networks. So maybe this makes sense. This particular recommendation is already taken into consideration.
Okay, could you? I was not aware of that draft. Could you send me a pointer?
We'll do that.
Use the mailing list, please.
Yeah, we'll do that. Yeah.
All right, great.
Malisha, as chairs, we care about when this document will be ready for last call, and we wonder if you think that considering minor additions that are discussed now, your next version would be, from your standpoint, ready for workgroup last call. Can we expect to do workgroup last call soon?
Oh, yes. So we need to take care of basically to tag the joint traffic joint proxy. This is the major addition that we do. And other than that, I mean, it should be ready. So I will be doing soon a new version. And I think we should go for the working group last call after that.
There is one thing, Malisha, is that you have a normative dependence on OSCORE.
Yes, so this is another thing. So OSCORE is in a working group last call at core at the moment. So I think my personal opinion is that minimal security should go to IESG hand in hand with OSCORE.
Hi, Malaysia. Göran Selander.
Yes.
OSCORE is not yet in working group last call. There was like a pre-working group last call. So they asked, is there any problems with this going to working group last call? So, but the meeting is tomorrow, so we know more about it tomorrow.
Oh, okay. I apologize. I misunderstood that.
So before Suresh, I mean, can you please, do you think there is a chance that at this point there is a major change in OSCORE that would impact this document?
Not that I know of. No.
Yeah, Suresh Krishnan. So I think it's going to be very challenging to like synchronize these two drafts. So if you think you want OS core to be done before you ship this off, just wait in it in the working group, right? Like so, I cannot do cross area synchronization of drafts. If it's like multiple things that are my groups, then I can manage to do it, right? But
Okay.
I would say if you're worried about like any changes in OSCORE, just wait for it to get through. I can hold on to it like until that happens, but it's probably just going to be me gating. There's nothing that's going to be synchronized between these two. Like we can put one of them ahead of another, but that's about it.
Yes, I mean, OSCORE definitely is the dependency. So OSCORE has to progress before, but we don't want to wait for OSCORE to be an RFC before we can progress.
Oh
this
no,
one
no,
either.
not for RFC. Like, but like if you wait for it to be shipped out of the working group, because like there could be changes at any point that could break us, right?
Only a major change, but yeah.
Right. So I'm pretty sure there's going to be some changes after it leaves the working group, right? Like there's IETF last call on IESG. I'm sure there's something that's going to happen. So if you want like it to be baked, then I suggest you wait for that to get baked, or just send it off and we can probably resync again, right? Like once they both go through the IESG process, if something breaks, like I can probably tell you like what has changed, and then we can go from there. So there's different ways forward. And another question I had is like, what's the status of like, the ad hoc and OSCOAP like stuff? I thought this was like for minimal security, right? Like, so I don't see anything in the draft. So I'm just trying to figure out like, is the dependency still there?
So basically, we removed the dependency on ad hoc in 04 version. And this has a consequence that we no longer support certificates for enrollment. We strictly rely on pre-shared keys now. And by doing this, we could remove the dependency on ad hoc and completely rely on OSCORE.
Okay, that's good for me to know, right? Like because this is like really 3-area cross-area stuff, right? Like, and if that's not a dependency, that's like very like useful input for me. So that's then I don't mind like just like the working group shipping it off to me, and then I'll figure out like how to get back. So because I think that was like the big thing that was like we haven't figured out yet, like because there's like a dependency on ACE as well for that to happen. So if that's not a dependency for this version of the draft, we can just go ahead with it.
Yes. So we removed this dependency, but as part of 6TISCH, I mean, I'm speaking on my personal on my personal behalf. We would want probably to have a secure enrollment that supports certificates, and we would need something similar to ad hoc down the road. So, I mean, we still want to do that at some point in time.
From Michael on the mic says, Zero Touch joins still use certificates and could depend upon ad hoc.
Yeah, I got it from your computer. Yes, thank you. Good to know.
I have one last question about the TOS bits. You say when we update minimal security, but I think that the tagging with the TOS bits and mapping the different levels that the TOS bits give us to different traffic may be a different draft rather than this one, or should be the same?
I think you need to indicate which class you're going to use, and that's about it. And for the rest, it has to be somewhere else, but you need to indicate that you're using a class, and that must be in the packet. And you also need to indicate that it goes into if there is IP in IP, then it goes into the inner, the one which is compressed by 6282 as opposed to 6LoRH, because 6LoRH cannot transport the class.
Okay.
Thank you, Malisha.
All right. Thanks.
So next we're switching from 1touch to 0touch. Then it's -1 is in touch. Michael, do you hear us? I think you can press the button. He's in the queue. No, he entered the queue. You're on, Michael.
Hello. Hello. Yes, I like that. -1 touch. So that's really good. And also, we should have imaginary touch for complex devices in the complex plane. So I'm going to talk very briefly about the zero touch effort. And next slide. Thank you. So the 01 version was posted on October 30th on the last date there. The 00 version had synchronized with the Anna Mabruski 07 draft that was at IETF 99. So the approach that I took was essentially to, we discussed the renaming last time, was to essentially wipe out the entire draft, pull the table of contents in from the Bruschi document, and then essentially make this a sort of delta draft so that the document, so it says, unless there's a specific something specific in 6TISCH join that's different than Bruschi, it would be identical, but that the table of contents is 1 for 1, so that you can go back and forth and say, you know, how is it different? The document is intended to be read, you know, more or less standalone, but you are intended to have read Bruschi. So with 09, the Bruschi 09 document, there were some changes to the document, and so the zero touch document resynchronized the table of contents, fleshed out a great number of text. It includes the Yang module, which is translated by the Core Yang CBOR mechanism into ownership vouchers that we need to establish ownership. This has been done manually. If you were in the core session a couple hours ago, then I guess there's now new complicated automated mechanisms to do this. And that will be great as soon as they become stable. So this document uses an experimental SID value of 60,100. And we need to get the SID document and the registry created to be able to make any progress here. And I think that they're about to do that pretty quickly. We had this big lunch at IETF 99 in Prague to try and sort out ad hoc and OS core and DTLS and all this stuff. I don't think it was particularly successful in the end. And I don't think we really have a really good idea of what will happen to ad hoc, if anything. So at this point, I'm writing the document on the assumption that it may live on top of DTLS or ad hoc or some other security if someone came up with a new thing.
You have a question?
So, hi, Michael. You're on Zalander.
Yeah. Yes, go ahead.
Just on state of ad hoc. So what's going on right now is that there is a comparison between, in terms of overhead, between the TLS handshake or DTLS handshake and ad hoc.
Mm-hmm.
And we didn't manage to do it in time for this meeting, so we will either have an interim or some sort of summary in between this meeting and next meeting, where we have all the figures on the table. We have a proposal for how the TLS 1.3 over co-op would look like, just a handshake, and
right.
How large that would be in comparison to ad hoc, and then match that against your requirements in terms of sizes of frames and so on. So that's the plan.
Right. So that would be a DTLS over co-op is one of the dots extra additional possibilities as opposed to DTLS under co-op, which is we already know how to do, right?
Yeah. It's going to be two concrete proposals which we care. One is which we compare. One which is based on a TLS handshake, and one which is based on ad hoc. And then we're going to match that and have a discussion based on your requirements on number of messages and so on.
Thank you. That's wonderful. But just as a little aside, one of the things that I realized in implementing is that DTLS, if has a distributed denial of service attack mitigation thing that involves an extra round trip. And so that would be one of the things, for instance, that we would have to decide if we're going to turn on all the time or disable or exactly what. So my last point is that I saw that the charter update says that we're going to do this by October 2018, and I'm pretty sure that we can beat that, because my feeling is that although this has sat in the wings for a long time, it now has the right steam to advance quickly, assuming that we figure out what security belongs underneath it. Next slide, please. There are a bunch of other dependencies and other works. So for instance, there is dependencies in the core working group involving SID, as I just mentioned, and the Yang stuff. There is a document that's currently would like to be in ACE, which describes how to run EST over COAP, and it would be silly to repeat that document in this document. And there is reluctance to merge the two documents at this point. Because it is believed that there are quite a number of uses of EST over COAP which are not related to 6TISCH or any of the IoT stuff. I'm still trying to understand what that set of things is, but that's part of it. So then we also have some documents, even in this work group, that this work has outsourced to, and they're not adopted either. So right now I'm the primary author. I would be very happy to have additional co-authors who want to actively contribute or who are even writing code. That would be great. But I am making significant progress on the document, so I'm not terribly worried about that. That's all I have today. Yep.
Hey, this is Peter van der Stok. It's about EST Co-op S. I hope to have a meeting with Hannes and some others to discuss how we go to handle this EST Co-op S, and if this should be two separate documents or if to keep them all together. And well, we'll keep you informed.
Okay. Yeah, I feel confident that you will figure it out and that we'll have a document to refer to very soon. Thank you.
Any other questions? Thank you, Michael. So we're switching. We're going into scheduling function territory now. Diego, I hope your issues are resolved. I hope you can hear us.
Hi.
Yeah, perfect.
There you go. Let's see if the video works. There you go. Okay. Well, I'm Diego, and I'm the editor of draft IETF 6TISCH.sfx. And can you move next, please? How can you move it? Okay, thank you. So the idea is that we are this is the work that continues the work that we have started on the on-the-fly scheduling and scheduling function 0 SF0, and this was the original one had a full experimental results. Okay, meaning that we had a paper on this. Okay, and then we had some recommendations that in the last version we have changed for the fundamental algorithm that adds or releases the cells. So the recommendations were first to resubmit SF0 as experimental, so we changed the name to SFX, and then to provide a list of requested experimental results. So to establish a range of values or the values of each of the constants you have used within the draft. Next, please.
Clarifying question. Did you make sure there is no leftover SF0 in the draft? Because maybe there are.
As far as I can remember, okay, we say that this is the experimental version of SF0, in fact.
There is one on the screen.
Sorry?
There
We
is
say
one
on the
and
draft that the SFX is the experimental version of SF0. Sorry. Yes. So yes, you are still using SF0 because this is the only experimental version of it. Then we the request is to define values for over provisions, SF0 threshold, and the other ranges. Okay, so as to auto delete on the education policy, and then we want to analyze the scheduling stability in terms of oscillation, because that's the main issue when you are trying to define how many cells you are going to define or to add or to delete on one side or the other to avoid in fact churn. And that's one of the features that SFX has. And next, please. To define a PDR value below the average, which is most effective, in fact, for blacklisting cells, and also to whitelist them, and then to analyze the stability, because of we've been working mostly on the idea that there's a percentage of them that they should be added or deleted, but we want to understand how many should be deleted or added, and then and measure the distribution of cell scheduling delay. Okay, and that way, and meaning that if we are going to add more delay, okay, when we just distribute in different ways, or to add more instances of the same neighbor on the same schedule. And next, please. So we have undergone a detailed review in May before IETF 99. Okay, and the corrections were submitted, of course, on SF005. Then, so my question is if it is ready for WGLC? Okay, the last call. That's it.
Any questions for Diego? So Diego, I reread the draft in the plane.
Yeah.
So I have a couple of editorial comments, and I'm happy to work with you on fixing those. It does state in some places SF0, SF0, SF0. So I think just a typos that need to be fixed. And also, I mean, it's probably entirely our fault, but at the beginning we started talking about SFs by their number, SF0, SF1. I mean, we're changing our minds because we get stuck with those numbers, and we're kind of assigning IANA numbers before anything has happened. So we now have 4 SFs, ASF, MSF, 5, SF1, SF0, and another one. What I'd like to suggest to scheduling function authors is to name their scheduling functions not by a number, but by some name. Like MSF is minimal scheduling function, ASF is autonomic scheduling function. So SFX is fine, but I mean throughout the text you're referring to it as SF with SFID0. I think we need to follow the process to do let Diana assign this. It's silly, but for example, for SF1 it applies as well.
Okay.
But I propose that we work together, you and me, Diego, and your co-authors.
Okay.
I can shepherd if you want, and then we just get this out. And so we have to work for that. We have to wait for that editorial update before we can consider workgroup last call, I believe.
Hi, Leo Thomas asked if Diego, if you have some experimental results currently available, like in terms of stability. Do you have some experimental results?
That we are asking for. Okay, on SFX. That's why it is experimental. We had already the original ones. Okay, that were published for the former version, but it's not for the new version. Okay, we have changed the main allocating algorithm. Okay, we don't have them yet. If you haven't, we are grateful if you have tested it. You can even use the OpenWSN code. It has a part of SFX implemented over there.
Mm-hmm. Yeah, and given that it's experimental, this is fine. So Simon is typing. ASF stands for Autonomous SF. Thank you, Simon. Autonomous San Francisco, I assume. I'm just joking. Thank you, Diego. Thank you for waking up early. I know it's early.
It's 5:50 now. It's okay.
Okay, thank you. Thank you. So the next presenter is Tengfei Chang, who will present MSF, Minimal Scheduling Function. It's remote as well. Tengfei, can you hear us?
Yes, can you hear me?
Yeah, we hear and even see you.
Oh, great. So hello everyone, I'm Tengfei and I'm coming from INRIA Paris, from France. I'm going to present the 6TISCH minimal scheduling function, which is MSF. So, okay. So the MSF is a scheduling function on top of 6P, and the draft defined when joining the work and how the communication schedule is managed in the distributed fashion. Next slide, please.
Tengfei, if you please, could you hold your mic a little bit closer, because this time it's a bit low.
Yeah, that's fine now?
Yeah, that's perfect.
Okay, next. Okay, so first, because the MSF is trying to using the minimal cell defining the minimal RFC, so we define some way to leverage the traffic on the minimal cell. First, we define the different types to allow sending on the minimal cell, which is enhanced begins, deals, and the join request and response message between the plugin and join proxy. And also the 6P transaction before the node have a dedicated cell installed. And also we limited the traffic on minimal cell for the enhanced begin or deals. It's only allowed to transmit with a ratio of 1 divided by 3 times n plus 1, where n is the number of neighbor. So the traffic on the minimal cell will no more than 2/3, and the rest of them are used for the join process and the 6P. And MSF defined 2 cell frame, and cell frame 0 is for minimal cell, and 1 is for the cell added by the MSF. Next slide, please. Next slide. Yeah.
There's a delay. We're on slide 5.
Okay. So first, the behavior for node when after its boot, there are 3 states. And first, the start state, the node has a pre-shared key, and it will go through the join process, which is defined in the minimal security. And then it goes to the 7 steps to join, and at the end of state, a node should synchronize the network, and it is also using link layer key it get from the join proxy, from the join process. And the node should also have a preferred routing parents, and it also has a dedicated cell to its preferred routing parents. So after that, the node is allowed to sending the deals and enhanced beacon for serving as a router of the other nodes, and also the join proxy for the new joining nodes. Next slide, please. Okay, so for the step to from start to the end state, it has 7 steps. First, after a node boot, it's a random choose the frequency to listen the EBs. And step 2, the node will listen for multiple neighbors and choose one as the join proxy. And step 3, it will go through the join proxy drawn process according to the secure drawn process. After the node drawn, and you will listen for deals to require a RPL rank to select a preferred parents. And then step 5, the 6P will yield to adding a single cell with the cell option where the bit TX, RX, and shared bit set. And it will add, use this 6P add packet sent to their parent to reserve one dedicated cell. And after the node has one dedicated cell, the node starts sending the enhanced beacon and deals. And meanwhile, the node should send the keep alive to their neighbors every 10 seconds to see if their neighbor is still active. So if not, we remove the cell to that neighbors. Next slide, please. Okay. So after the end of state, the node will start the scheduling function. So there are 3 reasons to changing the schedule. First, either for adapting to traffic, or switching of parents, or handling schedule collision. And all of them are done through the 6P packet. Next slide, please. Yeah. So first reason for adapting the traffic. First of all, a node always has at least one cell to their parents, which means there will be 2. One is one dedicated cell reserved by scalar function, and one minimal cell. And also we keep 2 counters to the preferred parents, number of cell passed, which we're counting how many dedicated cell has passed, and also the number of cell used. So this is counting when there's a packet needs to transmit on the dedicated cell. It doesn't matter the transmission successful or not, but it will +1 when there's a packet need to send. And the decision is made when the number of cells is passed to reaches 16. So when number of cells used is greater than 12, we add a cell. And if it's less than 4, we remove cell.
Okay,
Yes.
I got a offline recommendation. Num cells passed is I think it's better to say num cells elapsed, just an English thing. But anyways, we'll have to fix that.
I'll take that. Thank you. Next slide, please. Yeah. So when a node switched its parents, you would do 3 things. First, it counts the number of cells to its previous parents, then schedule the same number to the new parents, and then it's remove all the cells from the older parents. And for handling the collision, next slide, please. Yeah, thank you. So we're counting, we're detecting the schedule collision depending on the PDRs, the relative PDRs. So if one PDR of one cell is 50% less than the cell with maximum PDR, we relocate it. And to calculate PDR, we use 2 counters on the norm TX and norm TX ACK, which is if the transmission is ACT. And they always go +1 when the transmission happens and there's ACK replies. When number of TX reach to 256, and the both counter should right shift 1 bit, which is divide 2. So actually the ratio between them doesn't change. And this relocation only happens when the norm TX reached 256 one time at least to make sure the PDR is has enough statistic. I see there's a question.
Yeah, there's a question.
Yes, we have a question in slide 8. If we can go, please. Slide 8. And you ask, how did you define those values? Like 16, 12, 4. How do you define those values?
Yeah, the 6 is a number which can change. So the main reason is once there is a 75% of the cell are used, we add a cell. And if there are less than 25% cell used, we remove cell. So 16, 12, 4, this is a relative number. It's not arbitrary. It's a well-toned depending on the experiment results.
Okay, thank you.
So we should go to the other detail slides. Yeah. So there's other details defining the MSF. So the 6P signal command, MSF didn't use it. A rule for cell list, the cell are randomly chosen. And the 6P timeout value is depending on the PDR of the link from node to their parents, and also a factor. And the rule for ordering cell, we order the cell in the cell list by their slot offset. And there's no for the metadata field, we didn't use it. And we also defined 4 actions to handle different 6P error code. And the inconsistent handling, we already described it. So this is the whole MSF draft generally about. And we proposed it 2 weeks ago, and we did a simulation and experimentation to see the very first result for the MSF. Next slide, please.
Oh, before we go into the simulation, if I may. So you've seen that we have been discussing for the joint process that we'll use the class field of the IPv6 header to tag at least the joint process, and it has to be consistent with what the SF does. So there will be a need to add some text in MSF to say, for this class, the number are 4, 75, 4, 12, and 16, and you increment by 1 or decrement by 1, but that's for class blah. And for well, maybe you don't say for a particular class, but for a range of classes, right? So we can work that out on the mailing list, but there will be an addition that will be needed there.
Yeah. Thank you. So this is the simulator implementation done by Malaysia, and the source code is indicated by the link under the title. And the big figure in the middle is what it looks like when the simulator is running. And we did this for 100,000 slow firm cycles, and 15 nodes are chosen and randomly deployed in a 2 by 2 kilometer area, and each node has at least 3 neighbors. So we got some results on the right, and to see how MSF can converge. So with this, the figure on the right top, and you can see there's a yes.
There is a question for Simon. If the cells of 2 preferred parents are for transmission only, or are also for reception?
It's the bidirection. So it's for transmission and also receiving. But it's a TX, RX, and share slot, but it's only shared by the node and its parents.
Okay, thank you.
Hello.
Yeah.
Yichao from Toshiba. Hello, Tenfei. In your algorithm, when you consider the case of switching parents and you have to adjust your schedule. So, for example, if a node has, for example, 20 child nodes, and then that node switches parents, does your scheduling algorithm still like remove cells one by one, and then in other case you will add cells one by one? Like it's slide 8.
Yeah.
Yeah. So in your dynamic scheduling, you basically so if the traffic changes gradually, I think your algorithm works very well. But in the case of a node switch parents, which that node has many child nodes,
Yeah.
and then that probably cause a problem if you do it one by one.
I think that's slide 9, no?
Yeah, it's really next one.
Next.
Right.
Yeah. So.
Oh, right.
Yeah.
Okay.
Yeah, it's switching is from the node to their children. It's switching, but if the node has more children, it doesn't change anything between the node and its children, because it doesn't affect that part, right? Because I'm changing a parent. If I have 4 cells in my local and this 4 cells is for my children, it's to their parents rather than to their children.
Yeah. Okay, I get it. Thank you.
Right.
Okay, Melissa made as well a comment that say we count the number of cells with the old parents and add the same number of cells with the new one in a single 6-bit transaction. Yeah.
Yeah, thank you. That clarifies it. Thank you.
Yeah. So, okay. Okay, and also we did a real deployment on the IoT lab. We implemented in the 2 weeks with the MS app code sprint, and we deployed 35 nodes on the Suckley IoT lab site. And we have some preliminary results. On the bottom left, the first one is showing how the rank is evolved during time. You can see the node rank is very stays stable after join. And in the middle, we calculate the end-to-end reliability. So on most nodes, so almost all of them reached 100%. And for the duty cycle, all the nodes are averagely below 1%. So this is on the traffic with only one. The node will send 1 packet every minute. So they only most of them only have 1 dedicated cell in their schedule. So it makes sense all of them are average below 1%. Next slide.
If you could keep it within 1 minute.
Yeah. So this is with this result, running result, we have some conclusion. And first, it works, and also simple to implement. And we have the broadcast strategy on the minimal cell, and it's indeed to leverage the traffic on minimal cell. It helps for the join and also help for the 6B transaction. And there's something we also need to figure out is how to set the MS parameters as function. And also we have some knowledge learned from implementation. So when a schedule inconsistency is detected, the 6-bit clear request and response should be exchanged on the minimum cell, because if there is a schedule consistency there, if it keeps standing on the dedicated cell, it may just doesn't work. And also we need a limited backup of exponents on the dedicated cell because it's only shared by 2 nodes. Yeah, and also need a further experimental based on application scenario. Yeah.
You have a question?
Yeah. This is Charlie Perkins. I have a question. What is it that causes the schedule inconsistency? I mean, what causes it to arise?
So,
or is there more than one cause?
the schedule includes, yes.
So, Charlie, I propose that we're running out of time. I propose that
Okay,
you and me
that's
have.
fine.
This is a 6P question. I'm happy to have a chat with you. It takes 2 minutes.
Fine, thanks.
Thank you. Yeah. Last, please.
Okay. Diego Dujovne say, will it be nice to see traffic bars conditions on the experiments? Traffic bars condition? Bars.
Yeah, I agree. So this is a very preliminary result, and we will do that. In the simulator, it showed that, and it works well. But I agree we need to do on experiments.
We have to do those experiments. Yeah. Agreed.
Yeah. So that's all.
Thank you, Deng Fei, and congratulations to you and Marisha for implementing this in 2 weeks. It's impressive.
Thank you.
Thank you. So we're running a little bit out of time. Next presenter is Remy, talking about SF1.
Hello, Remy here. So, what is SF1? So SF1 is a scheduling function to reserve a track to a destination multiple hops away in order to fulfill the bandwidth and the queues requirements of the sender. And the track reservation is conducted hop by hop in a distributed manner. And basically, SF1 is a combination of RSVPTE and the 6P, in which RSVPTE is used for end-to-end resource reservation, and the 6P is used for the cell negotiation between two neighbors. And SF1 is triggered in two situations. The first one is when the sender has new instance to transmit the data to the receiver. The second one is when the sender has new requirements for an existing instance. And in the end-to-end perspective, once SF1 is triggered, the sender should send a pass message hop by hop downstream to the receiver. And upon receiving the pass message, the receiver should verify, should initiate a 6P transaction to verify if there are enough cells to fulfill the requirements. And if so, the receiver should send the reserve message to reserve these cells. And for an intermediate node, upon receiving the reservation message, the node should reserve the cells in one hop in the same way as in step 2. And finally, when the reservation message arrives at the sender, before the end-to-end timeout, a track from the sender to the receiver is built successfully. And the pass and the reserve message is defined in RSVP. We have done minor extensions to this message formats. And the pass message includes the sender TSpec objects to describe the flow and the add-spec objects to collect the pass properties. And we use 3 request objects to verify if the node along the road have the request capabilities. That is the time slot switching capability and the SF1 and the 6P capabilities. And for the return message, it includes the flow spec object to describe the bandwidth and queues requirements, and the label object to assign the label to the upstream node. And the parameters in the flow spec object are calculated according to the sender TISCH and the add spec in the pass message. And in case of three-step transaction, the 6P confirmation message is encapsulated in the 6P operation object. In one hop perspective, in two neighbor nodes, we note the upstream node as node A and the downstream node as node B. The one hop reservation is triggered by the arrival of pass message if node B is the receiver, or by the arrival of reservation message if node B is an intermediate node. And then node B should map the bandwidth to number of cells and the queues to constraints on cells. For example, the slot frame and slots offsite, etc. And then node B should initiate the 6P transaction with node A to verify if there are some qualified cells. If the answer is positive, node B should transmit the reserve message to node A. Once the reservation message arrives at node A, the cells between these two nodes are reserved and the label is also assigned. And more details can be found in this state transition diagram. And node A and the one half cell reservation is triggered by the aforementioned conditions, and then node B should conduct the curved mapping to find some qualified sort frames. If there is no qualified sort frames, the reservation fails, and node B should send the reserve error to the receiver, and the current reservation is maintained. So if there are some qualified slot frames, node B should initiate the 6P transaction on one of them, and if the transaction fails or timeout happens in this 6P transaction, node B can initiate a new 6P transaction on a backup slot frame, and if backup slot frame exists, of course. If no, the reservation fails. And if the 6P transaction succeeds, node B should transmit the reserve message to node A, and the reservation between these two nodes is updated. And we have updated the definitions for the track ID and the label in the latest version. So the track ID currently is 16 bits identifier. It is assigned by the sender, and the track ID is mapped from the tuple source and destination IP addresses repo instance, and the track ID is encapsulated in the sender template object of pass message and the filter spec of return message. And the label is 32 bits. It is mapped from a band of cells between two neighbor nodes, and it is encapsulated in the label object of reserve message. It is locally validated between two neighbors and assigned by the downstream node. The label is associated to a track when the return message is transmitted upstream. So for the next step, we will complete the definition of 6P and of SF1 to cover some objects and message formats. And of course, there is a gap to be covered, which is how to map the traffic requirements to number of cells and the constraints on cells. And we will also cover the items according to the suggested outline of 6TISCH. And most important is we are going to work on the implementation to let running code to support our draft. Thank you. Any comments?
Thank you. We're running out of time, so I propose that we take. I have a bunch of comments and a bunch of clarifying questions, but I propose that we do the discussion on the mailing list right now. Is that okay?
Okay. Thank you, Thomas.
Thank you very much. And with this, we are at not the top of the hour, but at like at the end of the meeting. Any other business before we close the meeting? Okay, Harry, nothing. Thank you very much. Thank you.
We need the blue sheets. Can you please, everybody has signed the blue sheets? If so, can you please circulate the blue sheet all the way to here? I don't know where they are. Everybody signed them? Remy, can you please stay? Okay, so thank you very much all for the participation and for the remote people to wake up very early in the morning. Thank you, Tero, for being with us. I can never thank you so much. Let me.